This is measurements. All right, let's go. All right, the diagram below not drawn the scale. What does it mean not drawn the scale?
Not accurate.
Not accurate, not accurately drawn. Shows a wooden toy in the shape of a prism with the cross section A, B, C, D, E. F is the midpoint and of EC. What does midpoint mean?
It's in the middle.
Middle, good. Of EC. And the angle BAE, meaning angle BAE is a 90-degree angle. So this angle A here is 90 degrees, okay? It says calculate the length of EF. Okay, let's look for EF. Right this up? Right this up, okay. So you want the length of EF. All right, so based on what we're given, we say that F is a midpoint, right? So if you look at the reason and the logics here, what type of shape is this? What shape is ABCE?
Square.
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 And if F, what do we know about opposite side of a square?
They're the same.
They're equal.
Yeah, they're the same. They're equal.
So if the whole length from A to B is 6, right?
That means
what is
F
E
of
to F? F is 3.
3.
All right, so we are reason now, F at 3. Good. Now, what type of shape is DFE? What shape is this?
Triangle. Triangle.
And what type of triangle is it?
Left or right?
Left, right. Right angle triangle. We don't have no left angle. Some like the students in the class. In a D class, left angle. Gradient and then left angle. Anyway, right angle triangle. No. There is a relationship that is found to be called Pythagoras' theorem, right? Where Pythagoras' theorem says that the square of the hypotenuse in a right angle triangle, the longest side is called hypotenuse, right? This side. Okay? So this side
it's called what?
ED. ED is called the hypotenuse.
Why?
Why? It's just a name that they give it to they give to the longest side of a right angle triangle.
No. Oh, the longest side. That's what I'm asking. The longest side is called that.
Yeah. All right. So it's a hypotenuse. Longest side, and it is side that is always opposite the right angle. All right. The hypotenuse is always the longest side on a right angle triangle, and it is always the opposite side to the right angle. Where is the right angle? Right there, so. All right. So the side opposite the right angle is always called the hypotenuse. Now, what Pythagoras says is that the square of the hypotenuse, in any right angle triangle, he has proven that the square of the hypotenuse, or hype square, is always the same as this side square plus this side square. Okay? So it's always the same as side 1. We can call it side 1, right?
Squared.
Squared plus
and side 2 squared.
Right.
Plus. Okay, so
side 2 squared.
So
improve that to be true in any right angle triangle. All right? All right. So you have to remember this equation to heart. This one is not given on the formula sheet. Okay?
Always remember that.
You must know this equation, this relationship. In any right angle triangle, the square of the hypotenuse is always the same as the sum of the square of the two other sides. All right, so which are we trying to find the hypotenuse in this case?
No, sir.
No, we're trying to find either side 1 or side 2, don't we? So if we fill in this equation properly, let's fill it in. We'd say the hype is what? Same as 5 square, right? 5 square is the same as, it doesn't matter which side is side 1 or side 2. So we can just put in side 1 is what? 3? 3 squared. And we don't know side 2, right?
No.
Plus, can I just put x squared? Because I can't want to write side 2 squared. All right? X squared. So what are we trying to find here? Is it x or x squared?
X squared.
Is it x or x squared? Look. So the length of EF is the length of E. Hold on. Hold on. What kind of working out made right there, so?
Come here, is it find the length of EF?
A DF, me I try to find it now. Right?
Supposed to be, yeah, EF. So which is the 3 we know.
We found EF is 3. So a DF we are trying to find, which we are use Pythagoras theorem. Okay? So same story. A same story, all right? So DF is x, right? So now we have to use Pythagoras theorem, as I said, to find DF. Good? So we don't want DF squared. What we want is just DF. Okay?
Okay.
So what would we do with this equation? What would I do with the 3 squared? Because we don't want it over here, so what would we do with it?
All right, hold on.
Wendy?
Yeah,
Wendy? Wendy?
So, sir, like we say, we're going to use this first thing, isn't it? And his thing is saying that the 5 square always equal to the side 1 plus the side 2 squared. Let me ask it, all right.
Okay. So may I ask you now, what would we do with this? Do we want the 3 squared on this side, or we just want the x squared on this side?
The 3 squared.
We need the 3 squared over here, sir?
No, we need only the x squared because that's what we're trying to find out, right?
Okay, right. So what we'll do is with the 3 squared.
Carry it over and turn it negative.
Negative 3 squared, right?
Yeah.
So would I get, I'm going to simplify everything, right? All numbers. 5 squared is what? 25? So would I get 25 minus 3 squared is what? 9, right? Equal to x squared, done.
All right.
All right. So work out that for me now. 25 minus 9 is what?
Everything we drop a calculator. We can use calculator. Huh?
In a paper too. Everything we drop a calculator.
16.
16. So we have 16 equal to x squared. But again, do we want x squared or do we want x?
X. We just want x.
So what do we do with the square?
We are going to add square to.
You gonna add square? No, sir, you're not add square. You do the opposite of square, which is what? What is the opposite of square? Trisha? All right, so we basically don't need x. What we need, x squared, what we need is x. So essentially, we find the square root of 16, and square root of 16 is what will be the value of x, and that will be the length of df, according to Pythagoras' theorem. All right, that will be df. So we say df equal to 4. Root 16 is 4. Okay. That's that.